Dear participants, now session is going to start. Let me introduce our speaker, Dr. M. Anand Kumar. Dr. M. Anand Kumar is working as an Assistant Professor 1, the Department of Information Technology, National Institute of Technology, Karnataka. His area of interest includes natural language processing, machine translation system for Indian languages, machine learning, deep learning for natural language processing, and text analytics. He has more than 115 research articles, Corpus Index to his credit, published in reputed international journals and conference proceedings. He has received around 900 Google Scholar citations for his research papers. He has completed the computing tool for Tamil language learning and teaching project funded by Government of Tamil Nadu, and the Tamil Malayalam subtitle translation system consultancy project for Sharp Software Development Limited. He has organized 4 international shared tasks in Indian languages, namely DPIL 2016, MTIL 2017, INLI 2017, INLI 2018. He is a reviewer for more than 25 reputed journals of Elsevier, Sprinter, ACM. He also edited a special issue on neural machine translation in the Journal of Intelligent Systems. He has developed NLP tools and resources, POS tagging, morphological analyzer, and generator machine translation for Tamil and other Dravidian languages. He has received P.K. Das Memorial South India's Best Faculty Award, CSE Junior 2017, a Research Excellence Award from Amrita Vishwa Vidyapeetham on Jan 2018, and Young Scientist Award in 2016 in the area of NLP. With this, I would like to welcome Dr. Anand Kumar M.
So I'll directly go to the presentation. So what I'm going to talk today. So this is a roadmap of my presentation. First, I just try to introduce what is deep learning. Anyway, I have seen the schedule. Some people talk about deep learning already. I just give a small idea about what is deep learning, and we'll see that how can you relate with the NLP and deep learning. And we are going to see something called a word-to-vec, which is called embedding, which is a bridge between the deep learning and natural language processing. So we'll see some details about word-to-vec. Fine. So when you're talking about natural language processing, so I hope you people are aware about language processing and text analytics. So I'm just directly go to the text analytics framework. So this is the text analytics framework. So this is applicable for 80 to 90% of the NLP or text analytics application. This framework is a common framework. It's applicable for 80% of the NLP or text analytics applications. So see what is happening in the framework. So we have something called a text corpus. So if it's a social media domain, if it's from the social media domain, then the corpus from Twitter, or Facebook, WhatsApp, or blogs, or any other news content or news comments, we can say that the text corpus. So the first step, what we are doing, the text corpus. So we are doing something, we are doing a pre-processing. It means that we are cleaning the corpus. We are removing the unwanted words. We can call it as a stop words, meaningless. I mean, the words which are not affect or which are not help the classification. Or we are having something called stemming and tokenization. Tokenization is a process of converting a documents or sentence into a individual tokens. You can call it as a words. And we have something other pre-processing techniques or kind of normalization, where we can see that social media corpus may contain a lot of noisy data. We need to normalize it. Okay, that's the pre-processing. It's a usual thing. The next step is a representation, where you are learning the representation. After you are parsing the corpus, you are doing a pre-processing in the first step. The second step, you are converting that pre-processed content into a representation. So this is a representation. So representation, yeah, the representation means here the deep learning parts come, deep learning or machine learning parts come here. So you are converting the text data into some numerical format. So that is a representation. We'll see that how we are converting in the numerical format and what algorithms we are using, recent algorithms. The last step is it's a classification. So if you want to do a classification, if you want to do a sentiment analysis, or you want to do a author profiling or any kind of NLP task with respect to text classification, you can do in a last step. So these are the 4 steps, important common steps for the text analytics. So you are collecting a corpus, reprocessing, and you are converting the corpus into numbers. I'll come to that, why you are converting numbers. And finally, we are going for the classification, that means application. What application you want, whether you want a sentiment analysis, or you want to identify the age, or you want to identify the gender from the text, so that you can do it. Like that, lot of classification things are that fine. So when you're talking about the third one, representation, so that representation only plays a major role. That is the scope of our lecture today. So I'm going to talk about the representation. So what is that representation? As I said, that it's a representation means it's converting the text to numbers. So meaningful numbers. We cannot blindly convert the text to numbers. So that is what the main scope of the lecture is, representation. Before that, I want to touch few things about the NLP and deep learning parts. Fine. So when you're talking about the text analytics or that NLP, natural language processing, what was the technology widely used? So people started from the technology called knowledge-based model or linguistic-based model. We can call this as also a rule-based method. It's a traditional method where linguist or a language expert, he will provide the rules to you, and your job is to convert the rules to programming. There is no algorithms involved in it. Everything is in terms of rules. Fine. So that is the first model. The second model is it's based on a machine learning or learning-based models, data-driven models. So where people started introduce the concepts called machine learning and deep learning. So we try to learn something from data. Instead of taking the knowledge from the linguist, the main problem in the earlier model, the knowledge-based model. So whatever the rule you are building, whatever the rule you are converting to your program, it is restricted. Restricted means the rules, the accuracy of the rules completely depends on the knowledge of the linguist. If the linguist is knowledgeable, he knows in and out of your language. Say for example, Kannada or Hindi or Tamil or English, he knows all the linguistic nature of your language. Then whatever rules he is producing, whatever suggestions he is giving, that will be definitely helpful for the NLP systems. But if we are depending on linguist where he is having a little bit knowledge, or I can say that he is having only 60% of the knowledge about that particular language. In this case, whatever rules he can give, whatever rules he can suggest, so the accuracy is only 60%. So that's what, as I said, that the problem in that earlier model is it's completely dependent on the knowledge of the human being. The first model, the recent model, whatever we are trying are called data-driven models. As you know, that data is called as a fuel. So it's a fuel now. It's in the current trend. We can call it's a fuel. So we have ton of data. So we have huge amount of data available in our hand from the social media, or not only the text data, image or multimedia data we are having. So network data. So we need some good learning algorithms to understand from the data, where we are depending on that machine learning models as well as the deep learning models. Okay, one step further, if we talk about, okay, so anyway, I'll say the difference between machine learning and deep learning in upcoming lectures. Fine. So upcoming slides. So when you're talking about this rule-based model and the machine learning-based model, there is always something called hybrid method, where the combination of rules plus data. So linguist is giving some rules and few problems, few issues we are solving with the help of data. So there are some limitations in the data-driven model also, because you cannot solve all the problems with the help of data. We may require additional help from the expert, that is called the rules, after a data-driven model or a before data-driven model. Hello? Is it fine now?
Hello.
Hello, ma'am. Can I continue?
Yes, sir. Yes, sir.
Okay, fine. So that is called a hybrid model. So the combination of knowledge-based plus machine learning-based model. The last one, what we are seeing is deep learning model. We'll see that what is the difference between deep learning model and what is deep learning model. Fine. So when we are talking about natural language processing and then deep learning, there are some important things gives the bridge. We have seen that. I'll go back and to this one. I have seen the third stage where we call as a representation. The model given in this slide, vector space model, Bega-First model, TF-IDF, or PMI, all are traditional models. So these models are developed in 90s, but few people are still using, few researchers or few novice researchers are still using these representations. But the advanced model of the third stage is called, it's taken from the distributional semantics called word embeddings. As I said, that's the main scope of the lecture. I'll cover that word embeddings. Before that, you should know that what is word embedding and why we need word embeddings. Fine. So this is, anyway, when I'm talking about the word embeddings, I'll talk about the types of the word embeddings. Now I'll just say a few things about deep learning. Then I'll just go to that the exact part what we are thinking. Fine. So I have seen that you people are already aware about deep learning. So I'll just ask a question because I want. I know that it's a very difficult. Today is a Sunday. You people will be very tired, and I don't want to be. It's a one-way communication. I want a little bit interactive session. So you have this last session of your FDP. I know that. So can I ask? I'll ask one question now. I'll ask, in a deep learning model, what is mean by deep? Why we are calling it as a deep? If anyone knows, please post your answers in a chat box. Quick. We have only. I'll give only 30 seconds. Participants, you can answer, or you can answer also. If you want to answer, you can unmute and you can answer. Many hidden layers. Any other answers?
So could you repeat the question?
What is mean by deep? Deep learning model. Why the term deep we are using in the deep learning model?
When there are more than one layers, then we call it as deep.
Why don't you call it as a multi-layer? Any other answers? Ma'am, I think, sorry, ma'am, your voice is not audible. Can you type otherwise? Can I type in chat box quickly?
Hello.
Hello.
It works with basic neuron cells, with basic, or you can say the preliminary cell. So
Okay.
it could be called as deep.
No, deep and neuron, how it's related, ma'am? Deep and neuron, nowhere related. Okay, I'll come to that. So participants, please have us. Please look at that. I am not talking anything about. I'm not introducing natural language processing, because as you know that the complete FDP is for natural language processing. You people are aware about what is natural language processing and then what is deep learning. That is the assumption I have taken. Fine. So the term why we are called the question is why we are calling it as a deep learning. The reason is not only because we are having the several layers, there are other hidden meanings for the term deep learning. So I'll tell that how our brain, as I said, that how our brain recognizes few things. Suppose you have seen me, you have seen my video 5 minutes before. Tomorrow or day after tomorrow, if you are seeing a picture somewhere, if you are seeing a photo somewhere in your mobile or somewhere, your brain suddenly recognize that, yeah, this is Anand Kumar. How it's trained. So this is, so it's already shown my face, and then with my name, it's annotated. It's tagged together, my face and then that information, text information, that is Anand Kumar. It's tagged together and then it's recorded on your brain. Okay, this is a one way that, so if you're showing the same face, a similar face, then it will retrieve that and then it will say that this is a particular guy. So this is how our brain works. This is a simple concept, but how it's storing the information, because your brain having lot of your knowledge or whatever information you have seen day-to-day life. So you are all your memory, everything is stored in your brain. How cutely it retrieves this information, how cutely it retrieves this person information. This because of the reason is because the reason how it's stored. This is stored, how quickly it retrieves. The same thing is because it's stored in a tree order, hierarchical order. The information in the brain stored in a hierarchical order. Suppose you are seeing some new car today. The information will be stored in a term like vehicle, under the vehicle car, under the vehicle SUV, under that vehicle SUV, I'm saying the example, brand of the car and name of the car. If you are saying the new car today, it is stored in this hierarchy, because this hierarchy is already there. Vehicle is already there, car and everything is there. Only thing is your brain finds where I have to store this information. I cannot store the information anywhere. Everywhere memory is there, I cannot store the information everywhere. So I have to store in a hierarchical order. Then only the retrieval is easy. Tomorrow, if you are seeing the car, your brain automatically will search from that vehicle and from the carpool. Then it will narrow down the search, and then it will find out, yeah, this is this particular car. That is the hierarchy. That is called the deep layers, several layers of your neurons. So that's the reason. That's the other reason why we are calling it as a deep. So the deep here in deep learning architecture also, we try to achieve the same. We try to make a system to store the information in layers. In layers means, can you mute Tusara? Okay. So in the hidden layers, in the multiple layers also, we try to capture the information. You are giving a car to the deep learning model. The model should understand that first, that is a that is a vehicle. So this is a SUV, like that. Each layer is responsible for each information. So that's the reason why you are calling it as a deep. So I don't want to say the popularity of the deep learning here. It's already known. 2016 itself, the Google Trends reached 100% in the deep learning. Still, it's maintained the same. So the reason is that the reason deep learning obtains many exciting results. Deep learning started with computer vision and image processing, and widely applied to language processing and audio processing and all other problems. So this is the R&D table. So I don't want to say that what is deep machine learning and then how it's emerged. I'll just due to time limit, I'll just say that we are in the era of the fourth stage, or the fourth boom of AI. Fourth boom, or some people say it's still a third boom of AI. As you people are aware that AI is not a new term. The term AI coined in 1947. Please remember, AI term coined in 1947 by the famous mathematician Alan Turing. With this name only, ICM is giving the Turing Award, and we are having a Turing mission, and everything is from his name, mathematician Alan Turing. Okay, so that is that AI is not a new term. How it's related AI and deep learning? So AI is a bigger subset. AI is a superset, and machine learning is a subset of AI, and deep learning is a subset of machine learning. You people may have listened this from any of your previous lectures, so I'm just skipping these things, and I'll directly move to my part. So this is the year-wise the emerging area. So AI rules the world starts from the 1950, and 80s onwards, ML was popular. Even though we are not talking about the AI, but the ML, whatever we have, we have worked on the 80s or 90s or 2000. That is part of AI. Now the deep learning is also it's part of AI and machine learning. There's a lot of applications of AI. So as I said that I'll spend some time here on what is the difference between the machine learning and deep learning. Then I'll directly go to the bridge between that NLP and the deep learning. Fine. So when you're talking about that machine learning, so we are giving some samples to, okay, before that, a quick question to you people, why we want machine learning? Quick question, 30 seconds to answer. Why we need machine learning?
To train the system and build a model.
Why you want to train the system?
Because we are not giving as in traditional way we used to give input and then algorithm and then output. The reverse type of procedure is adopted here in machine learning. First we have the output, that is nothing but data set that is used for training the system.
Output is not data set, input is data set.
That's what I mean. That data set, yes. And then we used to predict or guess how we human guess the things. So like that we are making machines to guess through the training.
Okay. So so whatever you are telling, I don't have the slides. For that, I remember that diagram. Actually, I can say that the earlier way means you can say the traditional way is a programming. Am I correct?
Yes.
So you mean to say that programming, we are giving an input and we are giving algorithm. And the program, the output of the programming is some output. Suppose if you are giving a Fibonacci number 5 and you are giving an algorithm, the output will be the equivalent to the 5 Fibonacci. That is a programming. That is you are calling as a traditional. Okay.
Yes.
Am I correct? The machine learning means what she tried to say is in the machine learning, we are giving a 5 number and then we are giving the Fibonacci output of 5. Suppose I cannot recollect the value of what is the equivalent of the Fibonacci 5, Fibonacci series up to 5. Okay, take the factorial.
1 1 3 1 1 2 3 5.
Total, ma'am, how much is coming? 5
4,
10,
I think 4 up to 5 na. Yes,
yeah.
4 number.
Total I'm saying that Fibonacci series. Okay, fine. So whatever it is, so I'm giving a Fibonacci number and then I'm giving output. The machine learning should say that the mapping between this input and output is Fibonacci algorithm, or it should give us some mathematical expression out of it. Am I correct?
Yes.
The first one is called the programming, and then programming, whatever we are using. The second one is called machine learning. Why my question, you just clearly understand the question. My question is, why you already have something called a programming. So why do you want to find out the algorithm? You already have the algorithm in your hand. You have a programming means whatever algorithm you are having, you can implement with the help of programming and you can solve the problem. Why you want machine learning? What you said is completely correct with respect to the difference between the earlier model, programming as well as the machine learning. This is not a question to only to her, it's a question to all. Why we need a machine learning? We have programming. I'll ask in this way, we have programming. Whatever is, if you are giving any problem to software engineer or programmers, they will solve the problem. Then why you want a machine learning expert, or why you want machine learning concepts and machine learning algorithms? I hope my question is clear.
Sir, for learning relationship between input and output.
Okay, learning relationship between the input or output is a machine learning. Yeah, why? Okay, again, I'm asking why you want to find out the relationship between input and output. Where your programming failed to identify this input and output, because there are a lot of models, not only the machine learning, there are a lot of other models are there, mathematical models are there to finding the relationship between the input and output. starting from the correlation and so much relational models are there. Why this particularly machine learning? Why we not? Where we are failing, where our programmers or where our programmers failed. I'll give a simple answer because due to time limit, I don't want to elaborate. Go on this discussion. Fine. Thank you for your answers. So my answer for this is why we need programming. Certain things we cannot solve with the help of programming. Certain things we cannot solve with the help of programming, because programming means, as I said, that the algorithm you are giving, your algorithm you are giving, Fibonacci algorithm you are giving. So the programmer is implementing that. So it means that you know that is a Fibonacci or that is a factorial. You know that how this input is converted to output. But certain things you know how to convert the input to output, but you cannot describe. Example, I'll say that. So as I said that you are seeing my face, and if I show my photo again, you can say that yeah, this is Anand Kumar. Now I'm asking you, can you write a program to identify Anand Kumar? Can you write a program with a complex program, with a complex rules? You can write a program. Definitely, it's not like you cannot. You can write a program with the help of complex rules. Eyes will be like this, nose will be like this, like that. You can write a program. Whatever. But the other problem is that program will only work for Anand Kumar. Now I am asking for the other person. Again, you have to write a separate program for that other person. It's a one concept called a generalization. Okay. So my point here is certain things you cannot solve with the help of programming. You know that. You know the input and you know output. I'm showing this picture. You are saying that this is car. So I'm asking you to write a program to identify that. With the help of simple programming, it's very difficult to identify the information, because that is how your brain works. I'm just asking here, if you are doing the programming for that, it means that you are developing a model. So that is the main difference between programming and the machine learning. That's what we need, machine learning. So how can you solve these problems? Where identifying the face, the example I have, as I said that. So I'm just checking the person. How you identify? You cannot explain that. You cannot describe that. How you are recognize this person is Anand Kumar. Now I'm just saying in a brain perspective, how the brain identifies this Anand Kumar. So we have shown lot of photos of Anand Kumar. Because of that, it identifies. Same thing I'm going to repeat in the machine learning algorithm. I'm going to show a lot of human photos, including Anand Kumar photos also to the machine, and I'm saying that yeah, this photo is Anand Kumar, this photo is Anand Kumar, this photo is Anand Kumar, this photo is say some Raghavendra, like that you are explaining. Now system understand that yeah, this photo means Anand Kumar, this photo is Harman Singh, this photo is Raghavendra, like that. System understood like your brain. This is how a machine learning works. So when you're coming to that machine learning model, see from the example, so we have something called a feature extraction, where you need experts, where you need a domain experts to extract the features. So whatever we discussed now, the problem is image processing, where we need image processing expert. But in case of deep learning, we don't want any experts, any domain experts. What we want is we want huge amount of data. The features also extracted by the algorithm. You can see in here, the algorithm only comes in the classification. Input, human feature extraction, classification. In deep learning model, input, feature extraction and classification we are putting together. That's what we are calling deep learning as a feature learning model. This is a main difference. So this is the main difference between the machine learning and deep learning. I'll go to that the main picture of that today's lecture. I mean the today's session. So this is the how that machine learning and deep learning the performance wise. Have a look onto this. This is not a scope of my complete lecture, so I cannot spend much time here. Anyway, I'll share the slides. You have a look onto it. I hope you have seen these slides in earlier presentations. Fine. Now I'm just going to talk about what the real scope of this lecture. Fine. So when you are saying about the deep learning based natural language processing, you can see here we have seen the 4 models, we have seen 4 stages, we have seen the 4 steps. Sorry, 4 steps we have seen. One is documents, pre-processing, feature extraction, and other one is the other last one is the classification. So this we have already seen. So documents, pre-processing, the second one, third one is the complete on feature representation. The last one is output classification. So when you are, as I said, the third one is called representation learning. The important part in the third one is this is representation learning. This is completely the classification. The important one in the third place is called, we call it as embeddings. Word embedding. This is a popular term in NLP, natural language processing, word embeddings. Whatever document we are giving after pre-processing, we are converting into word embeddings. What this word embedding will do, simply in a layman perspective, word embedding means it will convert any text, any piece of text. It may be a document, or it may be a character, word, or a sentence, or a paragraph. These things will be converted. Why we want to convert into numbers? Because you know that machine learning or deep learning models are mathematical models. It means that we are solving set of equations. It's a numerical operations. So you want the data should be in a numbers. Even though you are giving a text or image or a signal, so there are domain specific techniques to convert into a meaningful numbers. It should not be a random numbers. It should be meaningful numbers. That's what we are going for, the concept word embedding. Okay, so these are the applications of the deep learning. So I'll just directly go to that this one. So this we have already seen, I think. Okay, yeah. So I'll talk about some of the use cases of that NLP with respect to the other areas. The one important use case I want to talk about is NLP with respect to healthcare. So there are NLP is not a alone area now. NLP can be taken to NLP with education, NLP with academia. The research are happening. So to analyzing the manuscripts, to analyzing the student answer sheets, to analyzing your slides, to process everything comes under NLP with education. And like that, NLP in healthcare is there. NLP in legal analytics is there. So using NLP techniques, how can you analyze the huge amount of legal data, legal court case documents? So that is also the one part. Here, the healthcare perspective, you can see that how can you improve that document, clinical document? How can you extract efficiently? How can you extract? How can you find out the similarity between the cases? Suppose a new case comes and then we don't, as a junior doctor, he don't know what decision he has to take. He can refer the previous solved problems, previous solved clinical documents. So using the NLP techniques. Another point in that in the healthcare is actually the insurance agencies. So they are trying based on your behavior, based on your social media behavior. They can say that which insurance you want. So, or what are the financial, whether, because in India, we are not giving much importance to the insurance. In other countries, they will give much importance because the medical expenses compared to, India is very less compared to other countries. So they try to insure everything. So there we can use the NLP techniques to analyze their social media content, or you can analyze their behavior, and then you can suggest some of the insurance companies also want that. Fine. So now I started with what is NLP and then what is deep learning. I covered, and then I said that some of the NLP applications, and I explained about the linking between the NLP and deep learning. The linking is, it's a kind of a bridge where we are calling it as a feature learning, or I can say it's a word embedding, where we are converting a text to meaningful numbers. Again, I'm repeating, not a random numbers, meaningful numbers. So this is called a word embedding. You can see from this figure. So I have a set of documents I'm giving to the neural network. I have a set of documents I'm giving to the neural network model. I'm getting output like this. So each word in the document is converted to a set of numbers, not a single number, set of numbers. That's what we are calling it as a vectors, word vectors. Word embedding is also called as a word vectors. So a single word is converted to a set of meaningful numbers. Why we need this representation? So the reason for this representation is to make the classification easier, because you try to understand, or you try to extract the information properly from the data. If you are extracting the data, if you are extracting the proper information from the data, or proper knowledge, using that you can easily categorize the data. This text is written by human, this text is written by bot, this text is written by male, this particular piece of text is written by female, like that. So we need effective representations for of words, sentences, or documents for better classification. So what was the earlier model? There are models like one-hot representation was there. It was the earlier model. So what they will do is they'll convert that. This is a very popular model. People, you may aware that they'll convert the complete document or to a vector format. The vector will be like a completely sparse vector. Only the particular place of the location of the word will be 1. The remaining place will be 0. Suppose, for example, you have a document size 10,000 unique words. So what you have to do is 10,000 unique words you are having. So each unique word, I am saying that each word can be represented as a vector of size 10,000. So in the 10,000 vector, or except one place, all the places, all the values, all the places, all the elements will be 0. That one place represent that particular word. So this is a very, very old traditional model, one-hot vector representation. So the main problem in the one-hot representation is, one is the vector size. The vector size is huge, as I said, that 10,000. Other one is that the representation is not much meaningful. See that I have taken 2 examples of vectors, like for the word hotel and for the word motel. If I'm taking the 2 vectors, hotel and motel, if you are taking if you are finding the distance between these 2 vectors, and I'll get the value 0, because these 2 vectors are completely perpendicular. Not only these 2 vectors, in one-hot representation, all words are perpendicular to each other. All the words are perpendicular to each other. So in that case, any dot product will be 0. Any distance, if you are saying that the algorithm will say that these 2 words are nowhere closer. But you know that motel and hotel are similar words. But if this representation is meaningful, if this representation is meaningful, means you should get some meaningful value, some reasonable similarity index between the hotel and motel. But here you see that we are not getting that we are not finding the information. We are not we haven't identified that these 2 words are similar. That is the main problem in a one-hot representation. The next model people tried with something called a latent semantic analysis. This is based on the concept called singular value decomposition. So due to time limit, I'm just skipping this. You please have a look onto this one. Okay. Now I'm just coming to the things, the recent model, what we are calling it as a word embedding. So this model is based on the idea, or based on the I can say that based on the sentence given by the linguist Firth in 1957. He has given a sentence. He has given he has made a statement. He made a statement. You shall know a word by the company it keeps. The complete distributional semantics, whatever we are going to see now, the recent model, is based on this sentence. You shall know a word by the company it keeps. What does it mean? Can you people quickly respond? You shall know a word by the company it keeps. Participants? Okay, fine. So I'll continue. So the meaning for this is you shall know a word by the company it keeps. It means the by company means here is saying about the context. Company says about the context. We can understand this word based on the nearby words. So I'll give an example. I'll give an example later. Fine. So this is called a word to vec. This word to vec model is introduced in 2014. So Google introduced this model. Still the model is still the model rules the world. Different embedding advanced models are the variants are there, but everything is the base model is word to vec model. Okay. So the represent. So what is that mean of this? What it do then? So the thing is actually the word to vec, each word you are converting into a vector. The vector will be always a low dimensional vector, and it's a direct representation of the word. Low dimensional means the in the word to vec, the only two options are there, two dimensions are there. One is 100, other one is 300. Each word will be represented as 100 numbers or 300 numbers. So it's a low dimension representation. As we are saying that why we are calling it as a vector. Interestingly, the vector properties are matched with this word to vec. Vector property means vector similarity. The distance between the two vectors means the distance between the two words, whether the two words are similar or not. So we can identify based with the help of vectors. Vector means a set of numbers. What we cannot visualize a 100-dimensional. You can visualize only a 2-dimensional. You can see only a 3-dimensional. In screen, I can draw only a 2-dimensional vectors. Fine. The key idea here is, so the key idea or for the word to vec is to predict the surrounding weights of every node. So your job is to predict the next word. Your job is to predict the left word or the right word. That's what the surrounding words. We'll see that what is it mean. So the concept of the word to vec is don't count, predict. Don't count means earlier model based on the count, how many times the word occurred, they used to find out that they'll go for the probability. But the word to vec model is not based on that. We are using the neural network, we are using the classifier to predict the next word or to predict the previous word. Fine. The other things in the word to vec. Once the model has trained, then it can be reused. It's not application specific. If you train the model once, then you can use it for any applications. Once you train the model, then you can use it for any application. That's the main advantage. You no need to, if you're doing for a sentiment analysis, you can take the word to vec model, you can use it. In a computer vision, we used to call it as a VGG, and we used to call it as a AlexNet, or we used to call as a LeeNet and all. So these are all the pre-trained models for images. Like that, the pre-trained model for text on NLP is called word to vectors. So it's a pre-trained model. So once the model is trained, you can be used for any application. And yeah. So now I just have a question. I said that the word to vec model I explained, and I said what is mean by what is that statement behind this word to vec. You shall know a word by the company it keeps. Now we can see here, I have blurred the words here. You can see here I blurred a word here. Here I blurred. Here I blurred. Here I blurred. Can you identify that? What is that word? 30 seconds. Participants, can you identify? This is a very simple question. So what is that word? I am asking, I have hidden a word. I blurred a word and then I'm asking what is that word? Are you people there? Am I audible?
Yes, sir. You are audible, sir.
Yeah, a simple question I asked, no response from participants. That's what I doubt whether participants, any answers from your side? You can post in a chat box also. Okay, fine. Anyway, we are recording the session now, ma'am. Anyway, future it may be helpful for them. Fine. Okay, so that the blurred word is love, L-O-V-E. The blurred word is love. So how can you identify this? The blurred word is love. So based on the previous word and based on the next word, for example, you can see that I dash my mother. So I'm saying the term like interpersonal affection. So I'm saying something about what you can say, that being together and a successful relationship between two people. So attraction that includes desire. So this terms will help you to identify that this term is love. How you identify this word now? How we identify? How can we identify the based on the context? We can identify whatever we are given here is a context. Based on the context, we can identify the word. So what is the final goal of word-to-word model? The final goal will be, so you can see here the words, the word should be I mean plotted in this, plotted, or what you can say, that the word should be, I mean the related word should be I mean near, it should be closer in the graph here. It's a two-dimensional plot, TSNE plot. In a multi-dimensional also it will be the same way. You can see here how it's closer. So you can see here the clusters, you can see notion, concept, idea is one cluster, person, job, occupation in the other cluster, colors in other cluster, and you can see the cluster, you can see that all the relationship names in the other clusters. So this is what we are calling, this is the powerful, this is the output of word-to-word model. Fine. So how we attain the output, we'll see that. So before that, so other interesting application of this word-to-word model. So each word, as I said, that it's a vector. So you can see here, you can take a king vector minus, you can take the man vector. From the king vector, you are subtracting the man. From the king, you are removing the masculine information. You are adding the women information after that, and you are getting the word queen. So king minus man plus women equal to queen. So this is what this equation also possible with the help of word-to-word model. This shows the powerfulness. So you can see that the reason is, I'll just move this woman here. So what will happen? King minus man equal to women minus queen. In vector subtraction means we are talking about the distance. It means that the distance between the king and man is closely or somewhere close to the distance between women and queen. Yeah, this is true because these two are the similar words. So the same thing we are using in word-to-word model. In word-to-word, there are two techniques we are using. One is a SIBO model, other one is a skipgram model. SIBO model and skipgram model. We'll see that what is SIBO and skipgram. Yeah. So suppose you are taking a word here. The 5 words are there. 1, 2, 3. I'm taking example. 5 words I'm taking. Now I'm hiding this word. Center word I'm hiding. Window. I'm just hiding this word. Left 2 words I'm giving, and right 2 words I'm giving to the machine. I try to identify what is my middle word. So this process is called continuous bag of words model. The reverse is called a skipgram model, where you are not hiding the center word, you are giving only the center word as an input, and you try to expect the all other words as an output. See that you try to understand, you try to identify the other words as an output. So this is a second model. First one is a SIBO model, continuous bag of words, and second one is a skipgram model. In continuous bag of words model, you have seen that context is given to the system, and system try to identify the word, a target word. This is a simple process compared to skipgram. But in a skipgram model, only single word is given, and your job is to identify the context. Now, can you answer the question? I don't know whether you people are listening or not. Can you answer the question? I have given an example, no, this example. Whether this example is SIBO or skipgram. I'll give 30 seconds. put your answers in chat box. I haven't seen so far any
SIBO, sir.
answers. SIBO. Yeah, what is meant by SIBO? Mamat also said SIBO. Yeah, SIBO means, so you are giving the context. So I have given a context and I have asked only a one word as a output. So it's a SIBO model. So in here, suppose you just think about the reverse of that. I'm giving only the word love to you and I'm asking you to fill all other words in that particular slide. Is it possible for us to fill it? Definitely not. It will take much time to fill that word to fit the word in a skipgram model. Okay, this is the mathematical objective function of word model. So you can see here T represents a total number of words, and we are having a window of m. So I'm taking a minus m to plus m. Suppose you are taking a 5 words. So this m will be minus 2 to plus 2. Minus 1 value will be there, and minus 1, minus 2, minus 1, and plus 1 and plus 2. So we are giving here that we are giving condition j should not be equal to 0 because that is a target word. So that j is 0 means that information will come here. J of w of t. So this is the adjective function of word model. It's a very simple model. You have seen that what is maybe a continuous bag of words model. I'll explain with an example how what is maybe a continuous bag of words model. So again, we're repeating, we are predicting the probability of a word given by surrounding words. Nearby words will be given to the model, and your job is to predict the the target word or the middle of the word. So this is a single context example. It's a multi-context. Single context means the context also one word is the input and one word is output. Here context is multiple words are on. Multiple words are input and only one word as generating one word as the output. So this will be helpful in text classification models where you are pausing a sentence and then you want to find out the sentiment of the sentence, whether it's a positive or negative. So that's complete sentence you are pausing. So this is an example of multi-context SIBO. Okay, we are seeing about the SIBO model, and now we are coming to the skipgram model, where it's a reverse of the skipgram is the reverse of SIBO model, where one word will be taken, one will be taken, and then we try to produce all the context information. So that is very difficult to produce or very difficult to identify the context information. So in our earlier example also, just to think that I'm giving the same suppose I'm giving the same same exercise. Suppose I'm giving only the word love everywhere, and I'm asking you to fill all the things, all the remaining things. Is it possible for you to fill it?
No,
No,
sir.
definitely not. You cannot fill. The reason is actually that's what the skipgram models are powerful, because how many times how the neural networks will do that. Suppose here we'll take the SIBO model. I asked what is the word. People said that the word is love. Suppose you are saying that instead of love, you are saying that the word is like. So my job is I should say that no, it's not right. Instead of just saying that it's not right, no, I want to say that what was the error. So they can correct the error and then they can correct the what was the error. I should say that. I mean, I have to quantify the error. I should not say that no. You are giving the word like, I have the word love in my hand. So I have to find the difference. I have to find the difference error. That's the error is a difference. No? So error should be like, error will be like this. Error will be error equal to, so I have something in my mind, it's a love, minus you have something in your mind. Fine. So so this first one is love, this is like. So this is called skipgram model. Okay, So now I explain what is a CO model, and then I hope I explain the skip-gram model also. So you can see the example here. I'm taking a sentence, cat sat on floor. The cat on floor is taken as an input, and the sat should be in an output. Sat, the word, center word, you can see here. 5 words are there. These 2 are left word, these 2 are right word. Sat. Fine. So this is what we are doing in a word to word. So we are trying to understand the center word. Initially, this is a simple neural network model. This is not a deep neural network model. This is shallow neural network model. You can see here what is happening in the diagram. You have an input layer 1 and 2. If you are having 2 inputs, if you are having 2 contexts, and then you can say that 2. And you are having something called WT. WT with respect to the size is V cross N, and we have something called W also from hidden to output layer. Fine. So when you're talking about the input layer, 2 input layers we are giving as an input, and we are now, as I said, there is a lookup table. So whenever I'm passing that input layer to that matrix, suppose you can see here, the second place is 1. Second place is 1. Means that let me go to the second place. Second place you can see here, from the 4th place is 1. So the 4th place should taken here. So this is how that continuous backward model works. So after converting this continuous backwards, after converting the skip-gram model, so our job is to understand the relationship between input and output. Input and output means what are input to us, what is the output to us. Okay, this is the things we explain. And when you are explaining this, when you are when you are generating this W, this is a neural network model. Have an input we have, and you have a hidden layer, and you have an output. So when you are calculating input to output, then we'll get a weight matrix. Here you'll get the weight matrix. So here you'll get an first input matrix. Input matrix is between input and hidden layer. Second input is hidden layer to output. Okay, so now I'll just move to the next one. So far we have seen what is machine learning, what is deep learning, and then how what is meant by word embedding, how it's connected with the deep learning. We are seeing the real-time output, some of the few real-time output of this word-to-word model. Fine. So this is the other output of word-to-word model. So word is given, a word is given, and the word is given and the percent distance is given. So suppose if you are giving the word Sweden is somewhere, and then if you are using the word-to-word model, you are finding there is distance between the Sweden and other countries. So interestingly, the percent distance are much closer than the closer in the GPS. How these two words are how these two words are related, Norway and Sweden. Word, cosine, and word. Okay, so that is a word-to-word model. So the example you can see here, the Sweden is given. Sweden and Norway distance is 0.76. Sweden, Denmark distance is 0.71. So it will go like. So other relationship between the between the words, they respect to the linguistic regularity. You can see here the words man, women, mother, father, sister, brother, grandfather, grandmother, uncle, aunt. So like the dad, mom, like that. It shows some direction. So it's giving the direction that the linguistic regularity in this direction always follows the same direction. So this is the other example, third example. By country and capital vectors, you can see here. The country name is there, China, and then capital is Beijing. So these two are connected. Okay, this example you have already seen that the distance you can see here. Here, distance between the origin and the queen is roughly equal to the distance between origin and king. This we have already seen that. This shatters competitions in this particular area. So hyperpatricium, hate wall, offensive wall, all other applications. So other interesting applications are identifying the fake news, directing the rumors, and other things. Now the recent research moves towards working on the math question answering as well as the scientific papers. So these are the competitions. The slides I'll give if you want to download and make it. Another thing is conversational data. The famous conversational data is quad data set. Machine comprehension can be applied in the machine comprehension also. Conversation system, machine comprehension, fake news detection, then style change detection. Inventory organization. Yeah. Okay, that's the conclusion. So I want to say that this is an interesting area to work on. So I'll just give a small I'll summarize that what we have seen, that we started with what is mean by deep learning and how it's related with natural language processing, and we have seen the bridge between the natural language processing and deep learning. It's called a word embedding. Quickly we have seen that what is meant by word embedding and how it's working, and there are a lot of word embedding tools are available. If you are not getting it, please contact. I'll send you that. I'll give you the list of tools, and that we are having something called the recent models are called the BERT model is there, and Smith model is there. These are the Glow is the old model. These are the advanced models of word to word. So you try to implement the word. I mean, the implementation wise also BERT is available online. So try to implement it as early as possible. Fine. The other point in this lecture is actually before concluding. So the good number of we don't have the lack of sufficient annotated training data in this area is an important hurdle. But that other point is there are a lot of interesting shared task competitions are available where you can download the data and then you can make use of that data set. It's the first one. And dealing with the code mixed script. Now I am seeing that a lot of papers in code mixed text are coming. So here you can start thinking about how can you work on the code mixed script for these languages and publications. So this area is a little bit compared to other things. It's easy for publication. People won't expect a huge novelty here. Even the novelty is not there, paper may get accepted. That's it from my side, and this is a close. This area is again the final point. Close area related to data science. You can say that text or information science. So where there are a lot of job opportunities are existing. So now I'm stopping. So I'll have 10 minutes I'll give for any discussion or question answer. Thank you.
Thank you, sir. Dear participants, any queries or discussions with the speaker?
Hello. Sir,
Hello.
can we directly apply word to back on Indian languages?
Yeah, definitely. We have word. We applied word to vec for Tamil and then applied for Hindi and Kannada languages also.
Okay.
You can retrain the model. Only thing is you have to collect. There is a recent model called BERT. I'll put it in a chat box where they are having an Indian language pre-trained model also. I'll just type that. You can see here. BERT, B-E-R-T. BERT for Indian languages. You check the search net, you'll get it in this website, Hacking Fees website. Any other questions? Participants? Yeah. BERT is a transformer model.
Okay, I think no questions from the participants.
Okay, okay.
Okay. Thank you very much, sir, for your wonderful and informative session. And actually, it was interactive session also. And you touched upon the topics like word to vec conversion, that is conversion of word to number, and one-hot representation and distributional scenario semantics, and skip drum, and also related to BERT model also you have explained. And the major thing is you explained how to discriminate between deep learning and machine learning algorithms. And thank you very much, sir, for your wonderful session.
Thank you, ma'am. Thank you.
Sir, please
Thanks for
share
winning.
your slides, sir.
Yeah, definitely I'll share. Now itself I'll share.
Okay, sir. Thank you, sir.
Thank you, participants. Thank you.
Okay, dear participants, now we have a break for lunch from 1 to 3, so that we will meet at exact 3. From 3 to 3:30, we will have a feedback session, that is oral feedback session, and followed by conclusion, valedictory function, valedictory speech will be there. And from 3:30 to 4:30, you are supposed to write your test. And as you know, the rules and regulations are already given to you in the general instruction. And no rescheduling of the test. You have to answer for the test, and you have to send a form within 4:30. It starts from 3:30. And regarding feedback, already we have sent the link for feedback, both college level feedback and also adult feedback is form is active. Now you can fill the feedback form, that is both college feedback form as well as adult feedback form. Both the filling of both the feedback forms are mandate. Okay, then so we will meet at 3 o'clock. So both the filling of feedbacks as well as writing of tests you have to complete by today itself. Within 4:30, please don't postpone it. Filling of feedback form, because it is also mandate from adult side also. Clarifications you want, you can.